All right, everybody, this is lesson 1-3. We did not finish lesson 1-3 in class, so we are going to be finishing it by video. And I'm going to try to get us through it as quickly as possible so that you have plenty of time for homework. I am on page 20, and here is a picture of the vocab that you are responsible for. You will want to pause the video to either write these down or mark them in your book, but we got through all of them in class. All right, so moving on. We are going to be looking at protractors on the next page, which is page 21. Let's look at this one. This is the second one on the page. When we are looking at a protractor, we're looking at measuring angles. We can either classify the angle as being acute, obtuse, right, or straight, or we can get an exact measurement of the angle. So here you'll notice we have this angle, this angle, this angle, and then we have some larger angles. We have an angle that runs BOC, DOA, or even BOA. So lots of options, but let's practice measuring. So let's start with BOD. Angle BOD is an easier one to do because part of the angle is on this baseline that runs along 0. Now you always put the center of your protractor at the vertex of the angle, and then if possible you run one line of it along that baseline so that it is running along 0, either the 0 that goes with the top line or the 0 on the other side of the protractor that goes along the bottom line. Notice that the top line is going to measure a wider part of the angle and the bottom part of the protractor is going to measure a slightly narrower part of the angle, but in the end you still get the same information or the same measure for that angle. All right, so let's start with angle BOD. BOD, the angle BOD, opens from 0 to 65 degrees. What is the difference between 0 and 65 degrees? Well, of course, it's 65. So the measure of this angle is 65 degrees. What if we had measured it on the bottom? This ray crossed at 115, and this ray crossed along 180. So 180 minus 115 would still be 65 degrees. So this angle is 65 degrees. Let's look at the middle angle. This time we don't have anything running along 0, so we've got to look at where both rays cross. OD crosses at 65 on the top part of the protractor, and OC crosses at 135 on the top part of the protractor. Remember, we're dealing with absolute value or distance here, so we can either say the absolute value of 65 minus 135, or we can say the absolute value of 135 minus 65. Either way, we are going to get a measurement of 70 degrees. So angle DOC is 70 degrees. Let me check my math on that. Yes, okay, we're good. And now let's look at COA, last one. Let's use the lower part of the protractor to measure this one. Ray OA runs along the 0 baseline, and ray OC crosses at 45 degrees. So this is a 45 degree angle because it runs from 0 to 45. All right, and below that you have a quick reminder of the 4 types of angles that we talked about in class, and you have the descriptions of them to come back to. So acute, right, obtuse, and straight. Now, let's go ahead and look at example 2 where we're going to need to do some math. Find the measure of each angle, these angles on the protractor, then classify each as acute, right, or obtuse. So the first one they ask us to do is angle AOD. Let's look at angle AOD. This one will be easier because it actually does run along the baseline, so we can use the 0 on the bottom to be our starting point, and it goes all the way to 165. So the measure of angle AOD is 165 degrees, and that makes it obtuse because it's larger than 90 and smaller than 180. The next one is angle COD. Let's look at COD. COD. Neither of these run along the baseline. We can use either the top section or the bottom section. I'm going to use the top, and this ray OD crosses at 15 degrees. Ray OC crosses at 105 degrees. So we're going from, what did I say? 105 down to 15. So what we're going to have there is a 90 degree angle because 105 minus 15 is 90 degrees. or 15 minus 105 is negative 90 degrees, but of course it's absolute value. So again, the measure of angle DOC is 90 degrees, and that would be a right angle. All right, please flip your page. Oh, I'm about to lose my phone, I'm sorry. Okay, we looked at the things at the top of this page, which was congruent angles and how we mark them. Remember, congruent angles have to be the exact same size, and we mark them with 2 arc marks that are the same. Another thing that we learned was how to construct a congruent angle. Now we need to go down and look at the angle addition postulate. This should remind you of the segment addition postulate that I taught you in the videos for 1-2. And this simply says that when you have angles that are combined to make a bigger angle, one smaller angle plus the other smaller angle equals the larger angle. Or in this case, angle RQS plus angle SQP equals angle RQP. We can work backwards if we need to. If we know the measure of the whole big angle, then we can say the big angle minus one of the smaller angles will give you the measure of the other smaller angle. So let's practice that. We have some examples of that. And this is where drawing and labeling comes in super important. We have a diagram over here, and we have our problem right here. And I'll read you the problem, and I'll let you look at the diagram. It tells us that the measure of angle ABD is 37 degrees. Notice that I've marked that in the angle. The measure of angle ABC, the bigger angle, is 84 degrees. Notice how I marked that. I couldn't mark it inside because it would look like I was marking one of the little ones. So I do an arc that kind of goes outside of all the angles, and then I label it. So now we need to find the measure of angle DBC. I'm simply going to say the whole thing, which is 84, minus one part, which is 37, equals the other part. And the answer to that math is 47 degrees. So angle DBC is 47 degrees. All right, let's move to the top of the next page. We talked about bisectors in our lesson in class. We talked about a midpoint first and how that is literally the middle point of a line segment. And then we talked about a bisector and how a bisector cuts everything in half. It divides at the midpoint a line segment into 2 equal parts. So actually, we may not have talked about that in class. We may have talked about it in the video. But a bisector for an angle is the exact same thing. It cuts the angle into 2 equal smaller angles. So here we have an angle bisector that is ray JK, and it is cutting angle LJM into 2 smaller equal angles, the one on top and the one on the bottom. And we can use that information to do math because algebraically, if we are given some information for this angle and information for this angle, we can set them equal to each other and solve for any variables that might be in the problem. So let's look at example 4. Here's the diagram. Remember, draw, 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 label, label, label. They drew it for you, but had they not, you could have simply drawn this according to the instructions, and it could have been this way or upside down or facing one of the sides. It wouldn't have mattered. It wouldn't have changed the geometry. All right, so the problem tells us that ray BD bisects angle ABC. So we know that ABD and DBC are going to be equal. They also go on to tell us that angle ABD, which is right here, is 6x plus 3. So you can see that I wrote it in so that I can see it. And the measure of angle DBC is 8x minus 7. I labeled it. Take time to do this. Now they want us to find the measure of the whole big angle. Well, we were told that this was a bisector. Therefore, that tells us that this angle is going to be congruent to this angle. So to do the math on that, we set them equal. 6x plus 3 equals 8x minus 7. We are simply going to use our algebra skills here. We're going to get all the x's on one side. So we're going to subtract 6x from both sides. And that'll give us a 2x on the right. And we're going to add 7, since this is a negative 7. We're going to add 7 to both sides. And 3 plus 7 is 10. So we now have 10 equals 2x. Divide both sides by 2, and x equals 5. Now that is not our final answer. They did not ask what x equals. They asked for the measure of ABD, which is this angle right here. So we've got to plug our x back in, which is a 5, and say 6 times 5 is 30, plus 3 is 33. And this is how you would present your final answer. The measure of angle ABD is 33 degrees. All right, I'm going to do one more of those really quickly for you, I think. Let me look. Yeah, that's the last thing we've got to cover in our lesson. So let me do that really quickly here. These check it outs, remember, they're extras, and I believe the answers to those are always in the back of the book, so it's a good way for you to practice. But this time they drew no diagrams, so we'll have to draw it. And I'm just going to let you watch me draw while I read the problem. The problem tells us that ray QS bisects angle PQR. So let's draw angle PQR. And we have a ray that bisects it, and that is ray QS. So this is S out here. And then they tell us PQS is 5y minus 1. PQS is 5y minus 1. Draw, 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 label, label, label. PQR, which is the bigger angle, so I'm going to do this, is 8y plus 12. 8y plus 12. And they want us to tell them what the measure of angle PQ, no, I'm sorry. I think I might have done this wrong. Hold on just a second. Let's see, they told us QS bisects angle PQR. Did I do that? Y'all follow along with me. QS bisects angle PQR. PQR, yes. The measure of angle PQS, which is right here, is 5y minus 1. And the measure of angle PQR, which is in fact the big angle, is 8y plus 12. And they want us to find the measure of PQS, which is this one. So we're going to have to solve for y. I did do it correctly. Sorry, I doubted that. We have to solve for y and put it back in. All right, so let's look at how we could do this. This one's a little more challenging. What we have to remember is that this is a bisector. It cuts these two angles into two equal parts. So if this is 5y minus 1, then this is also going to be 5y minus 1. So let's try this problem. 5y minus 1, that's not going to work right there. You couldn't see where I was writing it. Let's try it here. 5y minus 1 plus 5y minus 1 equals the bigger angle, which is 8y plus 12. That has to do with our angle addition postulate. This angle plus this angle equals the big angle. The other thing we know is that two bisected sections of an angle, I didn't say that very well, but the big angle, and we have two smaller angles because the big angle was bisected. We know that they're equal to add up together to equal the big angle. So let's do the math here. We're going to have 5y plus 5y, which is 10y, minus 2 equals 8y plus 12. 8y plus 12. Now geometrically, we are good. We've done and drawn and diagrammed drawn and labeled our diagram. Now let's do this algebraically. Let's get, this is supposed to be a 10y. Y'all can tell that it's the end of the day and I am mistake prone. So let's get all our y's on one side. We're going to say minus 8y, and that'll give us a 2y on this side. Let's say plus 2 on both sides. That's going to give us 14. Y is going to equal 7 when we divide both sides by 2. Now let's go in and solve what they wanted us to solve, which is this angle. We've got to substitute our y. 5 times 7 is 35 minus 1 is 34. So the measure of angle PQS equals, and what did I say that was? 34 degrees. All right, that's the end of our video. I hope your homework goes well. There's one thing we didn't get to, and that is just above what we were just working on, how to bisect an angle. I will do that with you in class on Tuesday. If you have any homework problems about it, save them and we'll do them together. I doubt that you're going to have to do an angle bisector construction, but if they ask you to construct one, just wait for me for Tuesday. If it's a mathematical bisector problem, then go ahead and do it. All right, have a good one.